Let's go back to synergetics. Do you feel the material of synergetics 1 and 2 to be irrefutable?
Oh no, I couldn't possibly make that judgment. I think it's irrefutable in the sense that it's consistent, internally consistent. But of course anyone can come up with a philosophical system like string theory or negative universe or two-dimensional flatlands and have them consistent. So I think part of the aesthetics and the attraction of it to me is that I feel that we worked on it long enough that it is internally coherent. But only mathematicians and artists, I include, and physicists and engineers will judge the validity of the system. But I don't say Synergetics 1 and Synergetics 2. I say Synergetics because, in the first place, the two books fit together, dovetail like this. And there were two only because it was more than you could get in one volume. And after the first volume was out, he couldn't stop writing it, and I was delighted because if there's any more to add on, I wanted to get it all in the A, B, and C, and D particles, but the other particles came in the second part, and so it's just all synergetics to me. And I think that, what was your phrase? Did I think they were valid or?
Irrefutable.
Irrefutable. I think they're pretty well purged of internal contradictions. So I think you have a very appealing and original system of geometric analysis. And I think it's invulnerable and irrefutable in that narrow technical sense. But does this illustrate the way nature operates, which was Bucky's claim, and which was my chief motivation in working with him on it, to be, I wanted to have an exposition that was sufficiently exhaustive so that others could judge whether this is the way nature operates or not. That's an open question, and no one has voted on that issue, if that answers your question.
Has anyone tested Fuller's theory that nature operates within a truly rational coordinate system?
This is dogmatic. I'm not sure Bucky would like my saying it's dogmatic. Bucky's never occult or mystical or summoning the supernatural, but his assertion, contention, that everything is, as he would say, omnicommensurate, rational whole numbers, is an unproven proposition and may never be proven. But it certainly is a wonderful tool, and that has never been exhausted, it's never been tested. And I think the developments that we'll talk about later in the Buckminster Fullerene prove that there are symmetrical harmonics that others didn't anticipate. And it lends a certain validity to his dogmatic claim that it's all omnirational. I don't know whether it's all omnirational. And even if it isn't, this vision that he has of an omnirational world is so aesthetically and intellectually appealing, and so capable of triggering other ways of looking at technology, psychology, how we live and work together, that it was well worth the effort, regardless of whether it meets that test.
Why hasn't there been more criticism of synergetics? Or do you feel there has been?
That's my great frustration. There has not been any more criticism of synergetics because, for the simple reason, no one has to review his books because he's not writing a book in their field. And we are very, very caught up into disciplines. Everyone is an economist, or they're a political scientist, or they're deconstructionist in criticism, and whatever they're doing, he's not doing. He says, look, I'm not into that. I don't have to. I can ignore Fuller because he's not my shtick. And so with impunity, they can say, I don't have to. I can ignore him. Now, it's very interesting that one of the few disciplines that bit the bullet and took Fuller seriously was the American Institute of Architects. Now, Fuller always castigated architects as exterior decorators. He thought they were completely missing their opportunity to apply technology to provide shelter for men the way they should. And they really objected his definition of architecture, which is, I think, the most generalized ever done, is the making of macrostructures out of microstructures. Well, now, this isn't what architects think they do as they're leaning over the drafting table. However, they were shrewd enough, they knew that they didn't want to be guilty of the charge that a prophet is out without honor except in his own country. So it was rather painful for them to award the AIA Medal of Honor for that year to Fuller, but they didn't dare not to it. And at the time, I don't think he really had an architecture's license. That's one of the reasons he had to practice with Shoji Sadao, because he was above getting a license. He didn't have time for it. It wasn't contemptuous of it. He admired expert workmanship trade wherever it appeared. But the architects said, well, we'll never reform Bucky, but he is one of us. And he did. After all, as the Encyclopedia Britannica article says, none of their breed, no architect alive, has covered such a large space in a stable structure with so little material. Now, that's not the way they judged themselves, but they did acknowledge that he did that. And whether that's important or not, they gave him the medal and admitted him into their tribe. But the engineers, the physicists, the economists, that's not what, it's not what I'm doing. And the cartographers are particularly outrageous and contemptuous because maps are not made of triangles, maps are not called Imaxian, and there are a spate of wonderful books on cartography, and none of them pay any attention to Fuller's map, as if it doesn't exist. So I think, to answer your question, Robert, the real reason that the critics don't tackle Fuller is that if they really got into Fuller and understood him, they'd have to come home at the end of the day and tell their wives, well, I've been wasting my life so far. And they can't afford that risk. Now, that's the most loyal thing I can say about why the critics haven't laid a glove on Fuller. He's also very difficult. You have to learn his language. Physicists aren't going to take time off and spend a week learning Fuller's vocabulary. They're not going to do it.
This may sound like the same question. Having had problems in the past with academia, is it viewed by academia, talking of synergetics again, as just one more scientifically untenable speculation?
Oh, they haven't even said he's wrong. They haven't. See, one of my dreams through the past, since I finished Synergetics, one of my preoccupations, if I had some very wealthy benefactor and said, no, I have $100,000 or $500,000 to give her Fuller, how should I do it? I said, here's what you do. You establish a prize for graduate students in mathematics, MIT, engineering, physics, and you give the prize for their doing a paper saying, gee, Fuller was right in this respect, or Fuller was wrong in this respect. Because you can get very far ahead in academia by proving someone's wrong. That Shakespeare didn't write his plays, or it's a very fast track in academia. If you take a negative position that someone's wrong, I can't even give people a prize for saying he's wrong. And the fact that they won't come out and tear his structure apart and show the weaknesses and the wrongness of it is, to me, far more telling than the fact that no one's come out and said, by God, he was right.
Hasn't Buckminster Fuller been writing the same book over and over for the past 50 years? From 9 Chains to the Moon, Ideas and Integrities, Utopia or Oblivion, Operating Manual for Spaceship Earth, Cosmography, and your joint collaboration on Synergetics.
It's all the same book.
It is the same book.
It's the same book. And people say, oh, Dr. Fuller's going to talk to us. What's he going to talk about? Well, if they would want to talk, they have a subject that they've gotten a grant for or whatever it is, you can put any title on it you want, and he will start and include that title. But it's still because he is so synergetic. It's the role of humans in universe and what humans can do about it, and how they build up an understanding of nature from their experience. Now that's, I think, talking now, that's the first time I've used the word experience. And I think that's going to be the theme of these questions that you're holding there, is that he's starting from experience. And his constant, that's the constant theme that makes all of his books just one book. Because for him, experience is the only source of authority.
His personal experience.
No, just as an experience that any human being can have. This is the point. What I can do, you can do too. And this is why he says, I have glasses, I can touch, you can feel things, you can tell the difference between 4 beans and 3 beans and 6 beans. And that's where it begins. If I can do it, you can do it. And so it's not that he never claimed any particular, he always disclaimed any particular insight or intuition. But he said anyone using their own experience and touch and observation instead of tradition that's been handed down in textbooks will experience nature in a completely different way. And this is a source of his authority and the constant theme of all of his work.
Is Buckminster Fuller a kind of, dare I say, prophet?
He was a desperate man in that he felt he had a mission. And I think the most arrogant thing he ever said to me was, and he was a very modest man, really properly understood, he said, he can't sin. He can sin. Other people can't sin because they don't know the knowledge of good and evil. And he does understand how the universe works. And if he didn't follow his compulsion to explain it to his fellow men, he would be a sinner. And it's sort of like the Garden of Evil. He said, Sonny, you can't sin, but I can sin if I don't do my utmost to explain. So prophets don't explain. Prophets proclaim some divine inner secret vision. Bucky was never occult. And it was never some providential thing. He called himself a guinea pig. He was the only guinea pig he had. Prophets don't call themselves guinea pigs. No, he wasn't a prophet.
Thank you for answering on the what kind of prophet Fuller may have been or may not have been. I'm curious about why sometimes Buckminster Fuller sounds like a prophet. He sounds like he's about to offer us, or to make our situation very clear, our planetary situation very clear, and there are certain measures we have to take. And in a sense, he sounds like a prophet, and he sounds also very radical, very political.
I can tell you very simply, it's that he has no room for the supernatural. Prophets deal in religion, religions deal in the supernatural. And he has a mission, and he is driven, and he has a vision of how the world works. But prophets invoke some secret or supernatural or some divine source. And he appeals to nothing but experience and what every man can learn for himself. And this is profoundly subversive of all religion. So, I know what you're getting at, and I know what people think, but I think it's revealing that Arthur C. Clarke referred to him as the first engineer saint, because his approach to engineering is a lot more than just how do we build across the river, how do we save ourselves on this planet by doing so. And it's that sense of mission that gives him the aura of a prophet. But I think that phrase engineer saint, and just as in the 1930s, long before that, when Russell Davenport who was Wendell Willkie's campaign manager and had worked with Bucky on Fortune magazine, called Fuller the first poet of industrialization. Well, now, we've never had poets of industrialization because industrialization isn't the right field for poetry, despite Carl Sandburg and his poets getting into that. I think that's a very telling phrase, an engineer saint and a poet of industrialization. And I think the real clue to all of these questions that you've been asking is that Fuller isn't a prophet, or he isn't an infallible philosopher. He uses a status a poet, and he uses a strategy of a poet rather than that of a prophet. But he's a poet that deals not only with words, but with geometry, and with artifacts and technology, and his approach to them is in a poetic sense that it takes all factors into account, and he hasn't the slightest interest in conforming to verse forms, pages between books, something to be shown in an art gallery, all of the limitations of all of the disciplines and non-disciplines of poetry and artists. Even the artists, most of their pictures used to be in square frames with 4 frames, and you can never get him into any frame because he's constant being an artist, and it's a verb. Poetry is a verb for him, and nothing is static about this, so it never stops. And so he has the temperament, perhaps, of a prophet, but he is too disciplined and consistent to admit of the operation of the supernatural. And that puts him out of business as a prophet, I think.
I'd like to talk about politics. More to the point, world game, patterns of industrialization, geosocial revolution. What is world game?
World game was Fuller's device for dramatizing statistics. Statistics are not easily acceptable. But if you take his air ocean map and put it on a large enough scale that every one person can represent 100 million people, and you put them out there and they're all jammed together in China and very far apart in other places, it's an enormously graphic way of demonstrating to people the realities of world economics that they can never derive from a table with all the imagination in the world. So it was a form of exposition, a form of indoctrination, and a very powerful dramatic tool to demonstrate the interrelationship of nations, the artificiality and ridiculousness of national boundaries. Now, what's the other question?
Am I looking at some type of revolutionary package here?
Revolutionary isn't the word for it. He was subversive. He's subversive of every institution you ever heard of. But he didn't waste energy attacking any particular political systems. And so you could never, he was always very adroit. He didn't feel contempt for Nixon or Mao Zedong or Eisenhower, or he wasn't in favor of liberals. By temperament, he was a New England Republican, and he wouldn't have been seen dead, I think, voting Democratic any more than he would have gone out without his bathrobe and pajamas or anything. He was very proper in those social reflexes. His answer to politics, I'm not political. He didn't feel that the solutions were political. He felt the solutions were technological. And so politics, whenever you asked him about politics, he would just say, you're not asking the right question. So that's all I can say about politics.
Fuller often mentions the Dark Ages. What is he talking about?
Everyone studying history know that the Dark Ages were before the Renaissance, and when human progress was at a pretty slow pace and standards of living were pretty low. And some historians now say the Dark Ages weren't all that dark, but in any event, every high school student or educated person knows what we mean when we say the Dark Ages. He used the word the Dark Ages to tell his audience that here you and I are now in the Dark Ages compared to the kind of organization of the world of which we are capable now. We do not have to wait for some new invention. We do not have to wait for supercomputers. We do not have to wait for anything. We have the means now to provide all the food we need and the shelter for everybody. And we're in the Dark Ages because we don't realize that. Once we realize that, we will look back on this year now while I'm talking to you as a dark age because it was unnecessary ignorance. And he was transferring the metaphor of the Dark Ages of medieval times to our current situation, that we are in very dark ages if we only knew it, on what we could do.
If Charles Lindbergh is one of the great pioneers of flight, what is Buckminster Fuller the pioneer of?
He's a pioneer of how we look at ourselves. He's a pioneer of conceptuality. And he designed his artifacts only because he wanted to get across some abstract idea. And so Fuller's goal was far more ambitious than Lindbergh's because he embraced the whole electromagnetic spectrum of our experience and our capability and of our improved performance. That was a far more ambitious and abstract thing. He wanted to change how we looked at the world. He didn't do that, but he set us on a completely new path to do so. Lindbergh tried to do something very great, and it was concrete enough that he could achieve it, and he did, and it was a fantastic physical, mental courage, everything else.
Heroic.
But
yes.
It's not really a very good comparison, I don't think.
What would be a better comparison?
Well, I compare him to the New England Transcendentalists. I think Bucky could only have been an American, because if he'd been an Englishman, I don't think he could have avoided going to Oxford and Cambridge. I think Oxford and Cambridge didn't have nearly as many dropouts as Harvard did. Americans are more apt to drop out. The New England Transcendentalists, like his great aunt Margaret and like Emerson, were not over-impressed with the cultural achievements in Europe and were quite willing to think for themselves. And I would compare him America is a land of inventors by temperament. And he was liberated from cultural shackles, as it was perhaps much easier for an American to be than anyone else, if that answers your question.
Do we owe anything to Buckminster Fuller today? Do we owe him a greater understanding of his theories? A room at the Smithsonian?
Well, he felt being alive was a privilege, and he says every life that I'm awake, every waking moment is sheer romance for me. And he would say we don't owe him anything in that sense of an indebtedness. I think I could say that we owe ourselves the obligation to pay more attention of not just Synergetics, but all the artifacts he's left behind to us, and ask ourselves why we have exhausted. We not haven't exhausted, we haven't hardly begun to explore the application of any of them. But that's a debt to ourselves, not to him. This is the shelf of books which I call Synergetics collateral. These confirm developments in synergetics, including Haken, who has a whole discipline in synergetics which is only tangentially similar to Fuller's synergetics. And Bucky his first reaction was maybe it was a ripoff, but Hawkins' synergetics came out exactly 1 month ahead of Fuller's synergetics. But there are a lot of publications like this, and the documentation of the recognition of five-fold symmetry. And most of these authors don't know about Fuller, but some of them that do are very sympathetic. And of course, you know this is very much more in your line of braced domes. But I keep having to move more room as these books come in, especially with the Buckminster Fullerene. Because these Buckminster Fullerene books. And there's one that I have on order that actually quotes and mentions Fuller and synergetics, which few of them do. And that hasn't come yet. I expect to get that sometime in the next week or so. But this is a beautiful thing put out by Pergamon Press, including a piece by Curl on the developments of Buckminster Fullerene before it was actually recognized as such and so named.
These are some of the files.
These are my working files of things I try to, like, Bucky was always talking about Einstein's cosmic religious sense. And I keep quotes to try to authenticate Bucky's memory in some of these fields. And I have Synergetics collateral, analogs for computers, tetrahedron notes, and
Crystallography.
yeah, geodesic designs in natures, closest packing of spheres, topology, prime numbers, his fascination with prime numbers, precession, and magic numbers, different magic number systems, and of course, five-fold symmetry and quasi-crystals. And people I'm in correspondence with about them, including Richard Smalley here and Alan Mackay and Harry Croto in Sussex has been the most sympathetic. So, Fuller loved to file things. He thought he came up with chronophile, but I remember that we had chronophiles in the Navy. We used the same word. In case of doubt, it's the best thing to file by date. I like to file. I call myself a taxophilist. Taxidermists classify things by skin, and taxophilists just like to classify things for their own sake. So, when I wrote out this Synergetics dictionary, Fuller gave me the original of this because he thought it was so ephemeral. He said this is the way he does it, blackboards. He didn't think it was worth preserving, but I thought it's a wonderful illustration of how he progresses the, what he would say, intercommensurability of geometry and number and the closest packing of spheres. And this is the way he would, in a couple of hours exposition with a blackboard large enough, this is how it would all end up. And someone caught it. And the publishers were kind enough to put it in this book as a gatefold, together with this frontispiece that I'm very pleased with, because this is the constant theme in every chapter heading of Synergetics has these two figures, because there's almost nothing he writes about in geometry that gets very far away from these two phenomena.
And they are?
They are the minimum limit case of geometry. That's what they are. The linear tetrahedron and the stable tetrahedron. That's a potential tetrahedron. Everything for him was a potential tetrahedron.
Do you feel Buckminster Fuller has found a key to the great comprehensive patterns of the universe? And if yes, in so doing, or attempting to do so, is he redefining our position in the universe?
I don't know whether he's found those patterns or not. I know he was seeking them. I know that he was more attuned to larger comprehensive patterns than most human beings, and it's given to most human beings to have the capacity to do. I think he was absolutely unique, and this betrays his reliance on technology. I don't think anyone has answered the question of what is the role in humans in the universe. He loved that as a title for his speeches. What is the role of humans in the universe? Why are we here? And I think his most explicit and simple answer is that we are here in the universe as local problem solvers. Well, I'm distressed because to most people, they don't know what he's talking about. That doesn't mean anything to them. And what he means is explicitly, literally, local problem solvers. There are certain things that nature needs to be done. And I don't know whether Fuller would say this or not, but I suspect that the example of we need computers. Computers perhaps could be created biologically. Eventually they may well be created biologically, but the creation of computers by human intervention is to me an example of humans solving a local problem. And that nature uses humans to do things that otherwise couldn't be done, which is another reason that Bucky eschewed the word artificial in any sense. If man makes it, it's natural, it's not artificial. If nature permits it, it's real, it's natural, it's not artificial. He never used the word artificial because there was no artifice. And for him, and he above all humans, had a mission for solving local problems. And he says the lovely thing about solving problems is the minute you solve 3 problems, you find that there were 6 more that remain to be done, and it's inexhaustible. And he defines truth in the same way, as merely truth for him is a tendency and never a resolution, because he's preoccupied with process rather than a static pattern. And all these different avenues, they sort of converge. Does that make any sense?
Yes, yes, it does. It is my understanding of Buckminster Fuller that he wishes all of humanity to succeed. We hear the term, I believe it is even in corporate levels, a borrowed term, a win-win scenario for all. To be sheltered, clothed, and fed so that we can all move on to a greater destiny full of fresh knowledge and new discoveries. Is this inaccurate?
That's an accurate
viewpoint
statement of his vision of what could be done. And in fact, he feels it was the only possible course. If we don't do this, we all fail. It's either that or catastrophe. So, And in a way, this anticipates a great deal of more conventional ecological thinking, that we have to reduce the enormous disparities in economic circumstances of the passengers on spaceship Earth in order even for the richest to survive. We have to reduce and spread the resources. And Fuller would argue that there's never any pain in that, because he said even a poor person here lives better than the kings in the past. The resources available to them that they now have a command of that were unthought of even 100 years ago. So people say, oh, well, he's just an incurable optimist. And he always denied that. He was never sure we're going to make it. He was an optimist. He was absolutely certain that we had a chance. He was certain that if we did the right things, we could make it. But he wasn't sure that we would. So in that sense, he was not an optimist.
I get the feeling Buckminster Fuller is a very impatient man, sometimes angry. He seems to want us to move on to the next phase of our evolution. I get this feeling from 50 years of writing and trying to edge us on to higher plateaus.
I don't know the answer to that, but there are two aspects of it I can comment on. One is he had exquisitely lovely manners with people, and only, of course, he would lose his temper like all of us. But he had generally very nice manners and very kindness. He was particularly good with young people. And his impatience manifested itself on questions of integrity. If there was some course, he would, to go into Union Station when it had been butchered by architects and was so inefficient, would cause him almost sick. And I've been with him in Penn Station in New York, and he'd go into that enormous men's room there, the one where Jacques Kahn, the architect, died, as it happened later. But there were about 30 or 40 male urinals, and he would go down and flush any that people hadn't flushed, because this was just is part of being civilized, how people should live together and making the system work. And when it didn't work, or when he would see bad design, bad architecture, it was an affront to his sense of integrity, and he would be very impatient with that. The second part of your question, if I understand it, is that he thought, okay, here we are in the latter part of the 20th century, and he was in a big hurry to get to the 21st or the 22nd century, somewhere like that. And my answer to that is that only those people in his family and those that lived close to him or really could hear him talk realize how, for a gregarious person who would love to talk and be with people, he was essentially very, very lonely. Because having discovered this vision of how the nature worked and his own cosmos, and finding so few people to share it with him, it was an enormously lonely life. And I suspect that if he were here to answer that question of, now he's in the 20th century, is he in a hurry to get to the 21st century or the 22nd century, I think he might have rebuked us for asking the question by saying it was too much of a preoccupation with the local phenomenon of time.
I ask that question because he seems to want us to move beyond local politics and even beyond biological urges. I
wouldn't. I think there's some validity in that. He wouldn't even discuss. He just says, "I am not political."
But isn't world game the ultimate political?
Well, it's sort of, you see, like a city manager or the technocracy. There has to be some committee procedure. And when you get into his program for organizing economics and society, he never, and even education, he wrote Education, Automation, all of that, he never fleshed that out in the details that he did his geometry. And it's one of the reasons that I had a tendency to keep out of Synergetics the sociological, political, and economic part. And he resisted that and felt that the books he wrote after Synergetics were compensating for all of his economic and social philosophy that were not incorporated in it.
Why does Buckminster Fuller have to reinvent the world all by himself, from the English language to
because
the automobile?
He's acting for the rest of us, using our experience in... The answer to that, why he has to reinvent. Why can't he accept what everyone else has?
Yes, exactly.
And I tried to, and have a feeling for that in the first words of Synergetic, or before page 1, are dare to be naive. And he felt that our sophistication with all the cars we have and all the inventions we have, we're so preoccupied with them that we don't dare to be naive and go back to first principles and ask simple questions like, is something better than the car? So you say rejecting, reinventing everything. Rediscovering. He felt we were too much prisoners of our cultural circumstances and our cultural reflexes and our local habits and the way our PTAs operate and the way we run and manage things, that there are so many radical solutions that we're ignoring because we do not reinvent. And it isn't that Fuller has to reinvent, but he wants to illustrate how each of us can reinvent for ourselves. And that doesn't come through in so much of his writing, that so many of these assertions sound bombastic because he doesn't keep repeating, I'm just showing what any one of us can do. And so there seems to be a lot of first-person singular and egotism there, which he, when challenged, could very quickly dispel.
We ended yesterday, well, we mentioned, I think very partially, something about the Fullerines yesterday. And I'd be very interested in finding out what are they, and where did the name originate, and what are we looking at?
They are an allotrope of carbon. An allotrope of any element is atoms of that element in a stable configuration. And carbon, although it's not the most abundant element, it's the most important for life, it's the basis of all organic chemistry, has only 2 allotropes in the history of chemistry. One is diamond, where they're in a certain tetrahedral, octahedral conformation of carbon atoms, and the other is graphite, where they're in more of a shelf-like layer. And in the discovery of Buckminster Fullerene, they find them organized in a spherical, icosahedrally organized sphere, the shape of a soccer ball. It's not a pure icosahedron.
Where did we find these, or where we?
It's just the power of our new electron microscopes. They now think these pervade the world. They think they're probably in outer space. Matter of fact, Harry Kroto, who was in the University of Sussex, was in search for organic particles in space, and he teamed up with the people at Rice University in Texas, because they had the equipment. He was trying to get the equipment. It's very expensive equipment, and Rice has it, and he had the ideas, and so they collaborated, and their paper was published jointly, and published in Nature about 1986, I think it was, maybe later. Before this allotrope was discovered of carbon atoms forming themselves in a stable pattern, other than diamond or graphite, there had been some discoveries here at the National Bureau of Standards by a fellow named Schechter of aluminum manganese compounds, I guess they are, or molecules, organizing themselves in an icosahedral pattern which exhibits five-fold symmetry. And these patterns do not conform to the classic classes of crystallography, which is a fairly mature discipline, and it's changed very little in the Encyclopedia Britannica over the last 200 years. And some systems have 6 classes of crystal symmetry, and some say 7. But in any event, they don't provide for five-fold symmetry. It was one of the forbidden symmetries. And the reason that it has come in to dominate this last decade of chemistry is not because they were looking for it, but because they couldn't hide from it. And it wasn't until they invented telescopes that could get down to an almost atomic level of resolution that they discovered that there is five-fold symmetry in nature. And they weren't looking for it. And they didn't want to believe it. And they still find it very hard to conform to a lot of their chemical preconceptions. And this is sort of on the marginal, since it's down to an atomic level, it's almost on the threshold of physics, but it is a chemical pursuit, but it has certain implications for physics because of the properties of these molecules, which have properties of conduction and many applications for lubricants and for vessels for, well, there's just a whole blooming array. It was the molecule of the year when it was found, and it is, at this moment, there are literally thousands of chemists for whom this is their chief interest. And so I was very interested in documenting this because and I knew about it even before it was named Buckminster fullerene, because I've been watching developments in five-fold symmetry and that literature. Does that answer your question about what is Buckminster fullerene?
Yes, it does. The scientific community talks very excitedly about this discovery. But does fullerene just carry Buckminster Fuller's name? Because this is a new class of molecules that happen to look like possibly geodesic.
Well, it looked like a soccer ball, and then they could have called it saccharine. But then they called it Buckminster fullerene, and a lot of the scientists object to that and still do object to it because they think it's trivial. Smalley likes it, who, with Croteau, named it Buckminster fullerene, because it has exactly the same number of letters as the points on the soccer ball, because it's really a very short term considering all the meaning that it conveys, because the international nomenclature system for chemistry, the name of it is 6 or 7 lines long, and Buckminster Fuller is very short for that, Buckminster fullerene. Now, they've recently adopted the use of fullerenes as a generic for the various forms of it. They're fullerenes, they're fullerides, and all the chemical variations of the other associations that come from this. But the pure fullerene is C60, and then there's C72. There are various symmetrical harmonics of arrangements, quasi-spherical arrangements of carbon atoms that are varieties of the Buckminster fullerenes. And when I went down, as I did several years ago, to call on Smalley, sort of on behalf of the Fuller legacy and speaking for the estate, Allegra, and the Buckminster Fuller Institute, of which I was a director, and I wanted to say how gratifying it was to the family and heirs that he had named it for Buckminster fullerene, but hastening to assure him that we were not making any claims to priority on Fuller's halves, because this is a precious and understandable about chemists and their very integrity of who found it first. And we weren't making a claim that he knew all about this and had discovered it first. The claim I did make to him, and was that Fuller's intuition, and one of the major themes of synergetics, is that nature organizes itself spherically and geometrically, tetrahedrally and icosahedrally in patterns of nature that are more valid than the XYZ coordinate system of Cartesian and calculus that most scientists are familiar with working with. So I said that just as Fuller didn't do his math so he could build a dome, he built the dome because nobody understood his math. And he says, if I build a dome like that beautiful dome in Montreal, everyone can see for themselves that this is a totally spherical coordination. You have to start with holes. No bunch of engineers could sit around a drafting board with 30 struts and ever just come up with the icosahedron. You have to start out with the idea and see how many struts do you need. And the parts are subordinate to the whole, and that's what's synergetic about it. So I suggested to Smalley and to Croteau, who's been very sympathetic about this, and Croteau, by the way, when he was very young, came and visited the dome in Montreal as a young man, and was an admirer of Fuller and his works long before Buckminster Fullerene was discovered. And I met with him the last time I was in London, and I have a long correspondence with him and others in the field of fivefold symmetry, like István Hargitay in Budapest, and they are receptive to the idea that there may be intuitions of Fuller's that are relevant to their scientific work. But I have kept assuring them that Bucky didn't follow their rules. He didn't want to publish a chemical paper or an engineering paper. He was following his unfettered intuition. And it was that intuition that asserted that the role of fivefold symmetry anticipates the way nature actually performs, and this wasn't triggered until our telescopes got powerful enough to see that there were, in fact, these things materially manifest, that there was a great big breakthrough. And as for the future of Buckminster Fullerene's, quite aside from the practical applications, some people even go so far as to say that it's going to require a reorganization of the periodical table of the Mendeleev's, not Mendeleev, the periodic table of the elements, because it is on the threshold of an atomic and molecular threshold that doesn't, all the questions aren't answered by the periodic table. But I think even more startling and surprising and suggestive is the idea that all of our chemistry of the 20th century derives from the benzene ring, which was a hexagonal planar structure in which most all of modern synthetics derive from the benzene ring, a whole new field of chemistry, everything from rayon, the whole world of synthetics derives from that. And some of these chemists I talk to suspect that the two-dimensional hexagon benzene ring, what that did for 20th century chemistry, the three-dimensional spherical Buckminster Fullerene soccer ball may have a comparable impact on the chemistry of the 21st century with a three-dimensional rather than a planar model. So now I'm not a chemist, I don't know, I'm a science writer, and I try to be an honest reporter of what people say to me. And of course, this is a thrilling validation of Fuller's intuitions. And I like to think that on whatever cloud he's sitting on now, he can see this kind of confirmation from the most unexpected kind of quarter, because these are people that were not championing him. And they still, most of them, have the conviction that the naming form was coincidental or trivial. And I think that it will be some time before scientists and other scholars recognize that there are aspects of synergetics of which this is only a physical manifest example, but there are further resonances of Fuller's intuition that might also have implications for chemistry, biology, and other disciplines of science.
So I get the feeling here that Buckminster Fuller was or is on the right track. Things are being confirmed here.
It validates that there are patterns in nature that conform to his method of analyzing nature when he rejected the Cartesian method. And he started out with his new radial circumferential coordination of a spherical geometry. And this is of particular persuasive kind of validation because it shows up in the most exquisite kind of physical measurement that there's nothing mystical about it at all. This is just, it's physics, material science.
Do you think that maybe now, because of this new discovery, people will go back and look at synergetics?
Very slowly, very slowly. Synergetics is still pretty inaccessible. You've got to learn its vocabulary. You've got to start, and it takes an enormous span of attention. And all of the aspects of it have to be kept in sort of suspense. Bucky's last book, his valedictory work, Cosmography, that Kyoshi Kuramiya did such a wonderful job for 5 years, his lonely task of getting that all together. That text was a magnificent accomplishment. It hasn't received the critical recognition it deserves, except to its credit by some magazines like Nature, the very prestigious scientific magazine published in London, reviewed it seriously, critically, but seriously. In that book, Cosmography, Bucky has 100 pages of exposition of precession. Precession is the phenomenon that operates in a gyroscope. And it's a counterintuitive phenomenon. It's not a common everyday reaction like the lever. And Fuller maintains, and one of the themes of this book is that nature operates precessionally and not in the linear pattern of most of our models. And it not only operates that way physically, but it operates that way economically, socially, politically, historically, psychologically. And he says humanity will still be living in the dark ages until they realize that their model should be a precessional one. So just as the Buckminster Fullerene is a model in the physical world, precession is a model that Fuller advances for broader than just physical nature in its applications. And for the reader to read 100 pages of exposition of exactly how precession operates, and then keep that in mind while Bucky reviews all the historical forces, I think we better. Cosmography is that it has not been widely reviewed and widely received. It is a difficult book. And so I don't anticipate that there's going to be any quick breakthrough or recognition. I think all of Fuller's writings, not just Synergetics, will stand the test of time. They're consistent and they're original. And before we close, I want to get to...
You were talking about precession, 100 pages on precession. I'm having a little bit of a hard time here.
Well, so did Fuller. Precession is a very hard thing to describe, particularly without illustrations, because he has a lot of illustrations to describe it, the way a gyroscope operates, and the way that precessional reactions are reaction other than 180 degrees.
There is precession, if I believe, between the movement of the planets.
That's correct.
Around the sun. Could we use that model?
That's correct. And precession operates that way, but we do not, we're not familiar with its operation at a micro scale and in the affairs of men and in the ways of our consciousness that he thinks we should recognize if we really want to understand society. So that's a very inaccessible proposition, and it requires a great deal of concentration to understand, because in order to understand it, you have to suspend most of the reflexes and training of everything you're brought up with. You have to say that maybe this unusual way of looking at the world has some validity. And so I don't think it's going to be quick.
It's going to sound like I'm going back on what we've already talked about. But there's a few questions I just want to throw in the air, and we'll see what happens. If you feel that's been answered, we'll just pass. Doesn't Synergetics outline and demonstrate the principles underlying this entirely new family of carbon molecule clusters? And that was the why of my question. Aren't people going to go back to Synergetics and maybe, I have a feeling that Synergetics here did demonstrate some of the underlying principles.
As far as I know, it makes no specific reference to carbon cluster molecules. Most of its message is implicit rather than explicit, because its whole explanation of the material world of nature and energy, the patterns of energy in the material world, follow a geometry that accounts for such molecules as Buckminster fullerene that are not accounted for by conventional geometrical approaches. I think that's fair to say. But I think it's going to be a very daring and imaginative scholar who can go through the pages of Synergetics and see other avenues and might be pursued also. Because what Synergetics is really about is a different way of thinking. People are very conservative about the way they think, and they are very reluctant to give up their patterns of thinking that they think have served them so well thus far.
So I mentioned earlier that Buckminster Fuller is probably on the right track. Can the burden of proof be finally alleviated from all those critics and cynics that nature's coordinate system is discoverable and knowable?
Bucky was very interested in proofs, and he got very upset when people said he wasn't concerned with proofs. He did not follow the orthodox procedures and methods of science in peer review and papers and measuring things, and he didn't discipline himself that way, although he had respect for it and he understood it, and he had respect for proofs. And he craves proofs, and he was very eager that posterity would accord him the kind of validation and proofs of which Buckminster fullerene is only just sort of a harbinger or a symptom of what may be a validation of his theories. But I don't think that he will get the kind of proofs that your question suggests that you get on scientific questions. Because for one thing, there are two reasons for it that come to mind. One is we don't study geometry as a hands-on laboratory science. It's not in our culture, which is what he does. And second, he takes all the licenses and advantages of a poet, and his presentation is poetical. And we don't sit down and prove whether Tennyson's Morte d'Arthur or whether James Joyce or whether these things they're not susceptible of the kind of proof that science is. But Fuller is vulnerable in that regard because he takes as a stuff of his poetry and his creativity the language and stuff and phenomenon of technology instead of just abstract or aesthetic speculation. And technology involves the behavior of the material world, and particularly as it interacts with human beings. And since that's the arena in which his poetic imagination operates, the kind of proof is not going to be the kind of proofs that we're used to in the past.
So you wanted to make a brief expose of what you feel Fuller's greatest contribution.
Well, it's not so much that as I'd like to talk on what I think is less appreciated aspect of his record. Everyone knows that he was a Renaissance man and that his genius flourished in everything from choreography to geometry to architecture, engineering, every aspect of almost every kind of human endeavor. He triggered his imagination and his originality. But I think what is underappreciated is the fact that he had the determination, the compulsion to start in an absolutely new place. And this is what makes him so controversial and what makes him so fascinating to me was the fact that he totally rejected the cultural traditions, not just those of Western civilization. I mean, he had a lot of respect for algebra, he had a lot of respect for Democritus, but he felt that he didn't want to learn from books, he didn't want to learn from teachers, he wanted to learn from experience. Synergetics he described as EFM, experientially founded mathematics. The experience that's available to any human being who can see and touch and feel. And he found that the basic starting point for humans' encounter with the physical universe is geometrical. And it's geometrical in the shape of a tetrahedron. The very word tetrahedron is very off-putting to people. A tetrahedron, the simplest description of a tetrahedron is that it's a pyramid. Why everyone knows a pyramid? Because we know they're in Egypt and we know what they look like. A tetrahedron is even simpler than a pyramid because a pyramid has a square base. A tetrahedron has a triangular base, and it is 4 triangles together, and 4 faces and 6 corners is a tetrahedron. And a pyramid is really actually much more complicated. It's a half octahedron. Every time Fuller saw a pyramid, he saw the other half of the octahedron way down below the surface of the earth, because that was the only thing that made it a symmetrical figure to him. But he arrived at the tetrahedron and tetrahedral coordination on a great many different levels. I think one of the most poignant passages in Synergetics is where he tries to think of an infant in the womb or someone insulated from all sensory experiences, and you hear an event, either a ping of the sound or a touch on your arm, or there is an event. And you don't have anything to make it a reference to. And then there's another event, and you know there's 2 events. And then you still keep listening or looking or whatever you see, and there's a 3rd event. And only till you get the 3rd event do you realize that there's a sequence. And you have some measure of whether the interval between the 1st and the 2nd and how that relates to the interval between the 2nd and the 3rd. And Fuller argues that not until you have the 4th event does it lock into a geometrical resolution that you can cope with and analyze with. And in the physical world, there's no such thing as an absolute plane. That's only in abstract geometry. But in the physical world of nature, nothing is an absolute plane. And so you have 4 events, and they can't possibly be 4 in the same plane, and therefore you have a tetrahedron. And that's the genesis of his conceptualizing of the phenomena of nature and why thinking, which he described as a dismissal of irrelevancies, is inherently geometrical. Conceptuality is geometrical. And it starts at that simple place of what he called getting nature into a corner. Now that is such a radical idea, and that is so remote from all the tradition of geometry and arithmetic of Western or any other culture. It's rational, it's not occult, it's not mystical, it's experimentally founded, and it's on the basis of experience. And his consistency on developing from that point his whole elaborate approach to how nature and how energy operates in nature comes from that point. And anyone might have come up with that idea, but very few of us would have had the self-discipline to adhere to that idea with such a commitment that he dismissed all the other reflex tools, references, the XYZ coordinate system, the Cartesian grid. He said, well, we got to the moon on it and it works. But man opened the wrong door to the universe. We opened a square door of the XYZ system. And that's not the way it works. And we can trick it around with, especially now with computers. Computers have compounded it so that the more irrational and the crazier and more contrary to intuition our mathematical tools are, the computers can handle them. And so in a way, that was something counterproductive about the introduction of computers, because they can compensate for our crazy mathematics as he saw it. But I think that the chief area in which he has not been recognized is the sheer courage, drama, originality of basing his entire system from a new starting point.